So, good afternoon everybody. So in this next video I'm going to deal with a exponential function, and I hope this is going to be my last video about all these problems about derivative zeros, stationary points, extremas, and points of inflections. So in this case we are dealing here, you see, with a exponential function e to the power of x. So let's see, our task is the same as always. We need to find the zeros, the stationary points, and the points of inflection. So, but however, since there's an exponential function involved here, there are some things we need to take into consideration. First thing is, since e to the power of x is defined for all real numbers, there is no need to consider a domain, so no domain is needed. So the first thing we do is we are going to start with the zeros. So to find the zeros, we take the function equation and set that 1 equal to 0. So we set 10 times x squared times e to the power of x equal to 0. Now it might seem difficult to solve this equation here for x. However, there's a small little trick, and if you know that one, it's no longer difficult to solve this equation. So consider this e to the power of x. This e to the power of x is always bigger than 0. So, and since the whole thing here is in fact a product, and since one of the factors of this product is surely never 0, the other factor has to be 0. So this whole thing is 0, just in case 10 times x squared equals 0. As easy as that. And now this is 0, just in case x is 0, so we get a single 0 at 0, 0. Okay, so don't forget this one. It's an important property of the exponential function e to the power of x, that function is always positive and has no zeros at all. So let us continue with the derivatives. So first f prime of x, and then f double prime of x. So first f of x, well, let's see, 10 times x squared, this here is a constant factor, and so let us split things like this. This is first factor and this is the second factor, so we are going to use the product rule to get the derivative of this thing here. So f prime of x, taking the derivative of the first part, which is 10 times 2 times x, the second part as it stands, plus first part as it stands times the derivative of the second part. And don't forget here, e to the power of x, the derivative is just once again e to the power of x. So nothing changes at all. So the first derivative here is 20 times x times e to the power of x plus 10 times x squared times e to the power of x. And don't get confused. If you look here, we have the same function we had at the beginning, but that's okay. That's simply due to the fact that the derivative of the natural exponential function is that function once again. So this is the first derivative. No need to simplify there. Sorry, here, mistake. It's 20 times x. Okay, so once again, we are dealing here with a product, and here with a product, and the whole thing combined with a sum. So we have a product, then a plus, and then a second product. So this means we are going to apply the product rule to this part and a second time to this part there. So f double prime of x equals, so first derivative of this thing here. That's 20 then times e to the power of x plus 20 times x times the derivative of the second part, which is e to the power of x, plus derivative of this part, which is 20 times x times the second part, plus the first part times the derivative of the second part, which is just e to the power of x. So I know this can be a bit confusing, but look, here, this is the derivative of this, and this here is the derivative of this. Just applying the product rule twice, okay? So now let us see, we have here 2 times the same thing. This means we can combine these two things to 40 times x times e to the power of x times x squared times e to the power of x. And that's my second derivative. So this is maybe the most difficult part of the whole exercise. Let's continue with the stationary points. Which means setting the first derivative equal to 0. So let's see. First derivative was 20 times x times e to the power of x plus 10 times x squared times e to the power of x, and that should be 0. Now, this looks like a rather difficult equation, however, it's not. And don't forget this step here, it's always that approach works for so many exercises involving exponential functions. First, we factor out e to the power of x, like this. And now we have a product which is 0, and one factor is e to the power of x. And now we can do the very same thing we've done up here. So this is surely never 0. This is always bigger than 0. So the second part has to be 0. So 20x plus 10x squared is 0. And now we have a really simple equation, so we can solve for x, which leads to x equals 0 or x equals -2. Okay, so important here, factoring out e to the power of x, and then we can just ignore it, because that's surely not 0. So we take the extrema and plug the 0 into the second derivative. Well, 0 into the second derivative is, you see here, this is going to be 0, this is going to be 0, e to the power of 0 is 1, so that's going to be 20, which is bigger than 0, so we have a Tiefpunkt at 0, and y-coordinate, plugging 0 into the function equation from the beginning, is of course also 0. Then f double prime of -2. So what do we have here? Well, if you consider the second derivative here, well, f double prime of -2, this is going to be here, this is going to be 20 times e to the power of -2 minus 80 times e to the power of -2 plus 40 times e to the power of -2. And if you consider this thing here, I mean, this is smaller than 0. So we have a Hochpunkt at -2, and y-coordinate is 5.41. Okay, so the last thing we need to consider are the points of inflection. We take the second derivative, set it equal to 0. So if you look at the second derivative, I mean, that was up there. We can do the very same thing we've done above. We factor out e to the power of x. Now, we have a product which is 0, and one part is once again e to the power of x. So this part here has to be 0. Okay, so we get 20 plus 40x plus 10 times x squared equals 0. We take our calculator and solve for x, which leads to x equals minus 3.41, or x equals minus 0.59. So we end up with 2 points of inflection with 3.41 and y coordinate 3.84, sorry, and second point of inflection minus 0.59 and 1.91. That's it. So this is it about this topic. After the holidays we will continue with the next one. Hope to see you soon. Enjoy your life. Tschüss zusammen. Adi.